Now let's move into filtering data. Because in real life, you don't work with the whole dataset at once. You always ask questions like show me only adults, show me users from Bangladesh, give me products above certain price, find names that start with a specific letter. That exactly what filter is. Let's do some advanced filtering. Therefore, I'm going to create a new file with name of 05 filtering. Okay, let's close all other files. At the very top, I'm just importing pandas and numpy. Then I am just declaring data. This is data variable, which is a type of dictionary. The dictionary, we got some data, and let's create the data frame from here. Df orders is equal this. Now we have order ID, customer name, product name, category, quantity, unit price. Just carefully look at this. We have quantity and unit price, but we don't have total price. Therefore, we are just going to make it df underscore orders total price is equal df underscore orders quantity multiplied by unit price, which is total price. Okay, so let's see, print this uv run 05 filtering. Okay, here we got order ID, customer name, shipping status, total price. You see some dot. Those actually hiding some data because all data cannot be shown in this table because it requires plenty of space. Now we are going to find out all the orders that is delivered. So delivered orders is equal df underscore orders and df underscore orders here shipping status is delivered. So let's print it out. Actually print delivered orders. From delivered orders, I don't want every field, so let's just select a few specific columns. First one will be customer ID, then total price, shipping status. Let's see. Yeah, we are getting all the items that has shipping status delivered. Okay, I have explained this previously. This is delivered electronics. Here from df orders we have df shipping status delivered. This is one condition, and the another condition is inside this category must be electronics. So again, let me just copy this, and actually let's make it order ID instead of customer ID. So let me just paste it here. Again, run this. Yeah, you know this. We have used this AND condition a few more times. Let's use OR condition in here. Let's make it delivered or electronics. So electronics, this must, let's make sure it is this pipe, so it will bring all the items that has either category of electronics or it is delivered. So let me just copy this and paste it here. Again, run this file. Yeah, we got a lot more file than the lot more items than the previous one. Now let's get some item that start with A. So starts with A is equal df underscore orders, then df underscore orders, then we have customer name, customer name dot string dot start starts with A. So let's print it out. Let me just copy this and paste it below here, and instead of delivered or electronics, let's use this start with A. Here A. Okay, start with A. We got only one item. Actually we must get customer name so we can understand better. Yeah, we got only one customer that name start with A, Alice Smith. We can do same for ends with. So let me just go with ends with A. Customer name ends with A. Actually this should be A. Okay, again we made mistake by writing Alice, but both of them will work. Once you write Alice, it will check any customer that names start with Alice. Here it will check any customer that names ends with A. We can also write condition like this for filtering. Just let me do like this. Long products, make it long products, and here the product name string, then the lane must be greater than 7. Copy this and paste it here. Okay, here is the problem we written previously. This is the problem, that's why we didn't get any items that ends with A. We only get starts with, because we didn't use this value as well. And here we need to write product name. Now let's see. Yeah, here are a few products that name length is more than 7. And yeah, actually this is the previous one. It got empty data frame. Let's go for age. Instead of A, just write age, ends with age. So let's go for age. Let's see. Here we got 2 customer that names ends with age. Here we can find all products that is mid-range. So just write like this: mid-range is equal df underscore orders, and in here df underscore orders unit price must be within, just write between 100 to 500. Those are all mid-range products. Let me just copy this and paste it here. Long products, in place of long products just write mid-range product and unit price. Let me just take a break in here, multiplied by 40. Okay, let's see. Yeah, we got all the products that unit price is more than, actually more than 100 and less than 500. Yeah, here it is, all the mid-range products. We can get all the top products or top orders actually. Let me just copy this and paste it here. Top 5 orders, top 5 orders, df.orders dot in number largest, then 5 order ID unit price. Actually we are only going to check total price, so just get rid of this and write total price. We'll get all those products that has highest price. So let me just copy. Actually it is giving me autocomplete, so actually not. Let me just copy this unit price, total price and unit price. Yeah, I made this mistake again. This must be top 5 orders. We'll get this top 5 orders. We can do same for bottom 5 orders. Let me just copy this and paste it below here, and in place of top just write bottom. The function will be in smallest. Previously it was number largest and the total price. Okay, let me just copy this and paste it below here. Again run this file. Yeah, we got all the order that has less total price. Here I'm going to use where clause. Just like SQL, we can use where clause in here. Filtered underscore prices equal df underscore orders fd, not fd, it will be df underscore orders unit price dot learn about where df underscore orders unit price is less than 100. Let's make it greater than, unit price must be greater than 100, and I'm going to print here pd dot data frame, actually this data frame in here, just make it like this. Original will be df underscore orders, and we'll have unit price dot head. After this just make a comma, and here filtered, we'll get filtered value in here, filtered prices dot head. Let's see. Yeah, it is working. Let's use mask. What actually mask will do, it will replace values where condition is true. This is exactly opposite of where function. Let me just copy the whole things from here and paste it here. Let's make it plugged prices, and if it is greater than 100, then make it, instead of where, just make it mask. If it is greater than 100, just make it high price, and flagged prices, just use flagged prices dot head. And now let's see what happened. High price, yeah, original is this is the value. All of them has high price because all of those values are greater than 100. Now let's work with date time filtering. So for that I'm just going to copy this and paste it below here, and again I'm just going to do like date filtered filtered is equal df underscore orders, in here df underscore orders, and order date, we have order date just here, order date, this is date range from 2014, previous 30-day frequency. Okay, df orders date is greater than or equal 2024-01-10. Just go with this on condition. Let's print it out. Print. Let me just copy this and paste it here. Filtered data, let me do like this, order ID and or order date. Let's see how this looks. Yeah, this is order ID and this is order ID, date. All of those orders has greater than or equal this date. If you want to add another condition, you can just do like this. Let me just use this and here. Okay, let's see. We'll get less items here. Those actually matches those condition. I'm not going to explain again because I have explained a few times. Now let's check the order only for January month of January. Jan orders is equal df underscore orders, actually df underscore orders, then in here df underscore orders order date dot dt dot month is equal on, and let's print out the length of the orders. How many orders we got in January, month of January. We got 30 orders in month of January.